In this video, we will listen to several data professionals talk about their experience of working with varied data sources and types of data.
So you'd be surprised the different ways that data can come at you. I tend to be a relational database fan, and so I spend a lot of time with SQL. And using the power of SQL to deal with moving data from one place to another, to deal with structuring of data, to deal with all the security details around data. But obviously, that doesn't apply to every scenario, and even when we're dealing entirely in relational databases, we're often moving data from one relational database to another, and especially when we're talking about one vendor to another, that can be challenging. The things that also get in the way tend to be the versioning. So sometimes the feature of something that you want is in a version 2 levels above where you are, or it doesn't work the same way as it did 2 versions ago. So working with multiple data sources is about flexibility. It's about finding the function that works and works with the performance you need. Moving data one time is usually not all that hard as long as we're sub-terabyte, but moving data consistently and continually and in a performant way can cause us to evaluate a lot of different solutions. So we really need to be open to new ideas and looking for new solutions that meet the requirements that we have.
Mostly I work with relational databases. They're extremely flexible and withstood the test of time. However, with the evolution of unstructured data such as logs, documents, XML, and JSON, their reputation as a cure for all of your data problems came under intense scrutiny. And most of data-intensive applications such as IoT and social media applications started to look elsewhere. For example, Google released a white paper back in 2006 called Google Big Table. And that idea quickly caught fire. For example, Cassandra and HBase came out of the same architectural model as the Google Big Table. And they became widely popular databases to solve some of the problems that relational databases fail to solve. For example, relational databases struggle a little bit with heavy write-intensive applications such as IoT or sensor data or social media data, because the B-tree data structures that drive or power these relational databases slows down due to their nature of the random reads and random writes for the heavy write applications.
It's an inevitable part of a data engineer's job to work with a variety of data. You will need to work with standard formats like CSV, JSON, XML, but also you'll need to work with proprietary formats. And you will need to get data in different sources, whether it be relational databases, NoSQL, or big data repositories. You will need to work with data at rest, streaming data or data in motion, and you might not have the skills to work with all of these different types of data sources from day one, but you need to be able to learn as you go and pick up these skills required for the project to work with different data sets, different data formats, and different data sources.
When it comes to the data formats, log data, XML data, JSON, etc., each of them comes with their own challenges. For example, log data is extremely challenging because it's unstructured, and you may need to write your own custom tools to parse the data depending on what you want to look at. Whereas XML was widely popular like a decade ago, especially with the SOAP protocol of the web applications. However, soon the web developers and the corporations discovered that it can be resource intensive, especially memory, because it has both the starting and ending tags. So then JSON came into the picture. They got rid of the ending tags and they looked like a key value pairs, and it saved some resources, and it is now widely used as part of the RESTful APIs. And then even newer versions of the data format, such as Apache Avro, were gaining a wide popularity because of the efficiency on how they store the data.
One particular situation where we were converting data from a Db2 database into a SQL Server database. And it was challenging because the way that each of those expect imports and exports to happen is a little bit different. The data was particularly challenging, and that's where a lot of your challenge might come from in these projects, is from the data itself. In this particular case, the data had a lot of different characters in it. So usually we're looking for a character we can use as a delimiter. Oftentimes that's comma delimited, so we can separate our fields using commas. But we also have to think about situations where we have data that has commas in it. How do we properly separate that data? How do we properly define our fields? And in this particular case, we had to use different separators for different tables because every single special character that we could think of was in one of those tables. And the special characters that weren't were sometimes ones we couldn't use for separation, such as the bell character.